Welcome back, Wolfpack. Today's lesson is 15.2 and 3, angles and inscribed quadrilaterals, and as well as tangents and circumscribed angles. Our content objective for this lesson is that you're going to be able to find unknown quantities regarding circles. So let's get started right away. First theorem, if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. We've talked a lot about angles either being congruent to each other or being supplementary. And supplementary means they are equal to 180 degrees. Okay? So that, for example here, angle E plus angle G would be 180 degrees because they are opposite. Angle E and angle G are opposite each other. Okay? So then angle F and angle D would also add up to 180. It'd also be supplementary. This is a quadrilateral, so all four angles together have to equal 360 degrees. Example 1, find the value of the variables. We will do A together and now, and then B we will do in class. Okay, so I can look and see that this angle plus this angle are opposite. So they're going to add up to 180. So y plus 114 equals 180. Subtract 114 from both sides. Y equals 66. Okay? So y is 66 degrees. That one's pretty easy. Now I'm going to look at x. I see that angle x is this angle right here, all the way from M to K. Okay, so it's this arc, intercepts this arc. Well, this arc is 132 degrees total when you add up 52 plus 80. Well, angle x degrees, is an inscribed angle. So if you cut that arc in half, since it's an inscribed angle, you will get 61 degrees. So x is 61 degrees. Okay? So we found x using our knowledge from lesson 15.1, and then we found y because y plus 114 had to be supplementary. Next theorem. If a line is tangent to a circle, then the line is perpendicular to a radius of the circle at its endpoint on the circle. Perpendicular is our word here. I spelled that wrong. Sorry about that. There we go. It was just in a letter. We know that perpendicular lines form right angles. Okay, perpendicular lines form right angles. So that means if this line is tangent, okay, right where it intercepts, it's perpendicular to the radius. So, example 2. In the diagram, RS is a radius of circle R. Is ST tangent to circle R? They're wanting to know, is this line tangent to that circle? Well, in order for it to be tangent, it has to form a right angle. Okay? Well, can I prove that that's a right angle? Sure, I can prove that it's a right angle if I'm able to prove that this is a right triangle. So if this is a right triangle, I have a side and a side, and then I have the hypotenuse. So I would say, well, 10 squared plus 24 squared equals 26 squared. And if this works out to be true, then I know it's a right triangle. 10 squared is 100, plus 24 squared is 576, plus 26 squared is 676. 576 plus 100 is 676. Which does in fact equal 676. So yes, this is a right triangle, which means yes, this is a right angle. So yes, ST is tangent to the circle because it's perpendicular. So we would say yes. Okay, so yes, but let's go ahead and explain it. ST is tangent to circle R, so yes, the Pythagorean theorem shows. So Pythagorean theorem, and I'm going to pause this, write the answer, and then press play when I'm done. Okay, there's the answer. Yes, and here's the explanation why. The Pythagorean theorem shows that this is a right triangle, okay? So since it's a right triangle, ST is perpendicular to RS. ST is perpendicular to RS because perpendicular lines make that right angle. So if it is a right angle, we know the lines are therefore perpendicular. So since they're perpendicular, therefore ST, this line right here, is tangent to RS. If it wasn't perpendicular, it couldn't be tangent. But tangents are perpendicular to each other. So if they are perpendicular, it has to be tangent. Okay? We'll do another one of those in class. You're not going to have to explain why, but know that we're going to want to use the Pythagorean theorem to prove that it is a right triangle, because then we're able to prove that it's a right angle and perpendicular. Okay, let's keep moving. Example 3 we will do in class together. We're on the back side now. Theorem. Tangent segments from a common external point are congruent. Okay, for example, this tangent starts at S, and this tangent starts at S. So that means this tangent and this tangent are congruent to each other because they start from a common external point. QR is tangent to C at R, and QS is tangent to the circle C at S. Find X. Notice they both have a common endpoint. They both start at Q. That means that they are congruent. So 3x plus 5 is equal to 32. When you solve for x, subtract 5 from both sides. We have 3x equals 27, so x equals 9. Simple as that, not too difficult. Example 5 we will do in class, and example 6 we'll do in class as well. If you want to take some time and see if you can work out these problems on your own and see if you can get the right answers, you'll be a better prepared student. Have a great day, and I will see you next class.